So hello everyone, welcome to my channel. So in this video we are going to solve this amazing and very easy exponential question, right? If you are new to exponential question, then this question is very good for you, right? So pay attention throughout the video. You will learn a lot from this question. So what is the question? 2 raised to x plus 2 raised to x equal to 4 raised to x. And we have to find both the solution, right? Real and complex solution as well, right? When we find the value of x, we will find both the value, real value also and complex value also. This is going to be a very interesting video to see what value we will get, right? So pay attention throughout the video. And now let's see. First of all, if I talk about only real values, right? If I want to find out only real values, that will be very easy, right? You can use so many methods. For example, if you use very easy method, hit and trial method, right? You will put different value of x and see for which value of x the equation satisfies. So if you put x equal to 0, then 2 raised to 0 plus 2 raised to 0, it will become 1 plus 1, 2, and this will become 1, right? So 2 is not equal to 1. So x equal to 0 can't be our answer. For example, if you put x equal to 1, then 2 plus 2 equal to 4, right? So you will get x equal to 1 as your answer, right? But if you want theoretical answer, right? So there are so many methods. For example, here I have 2 raised to x plus 2 raised to x, so I can write it as 2 into 2 raised to x equal to 4 raised to x, right? So if I divide 2 raised to x into here, so it will become 4 raised to x divided by 2 raised to x equal to 2, right? So it will become 2 raised to x equal to 2, right? Here again base is same, so you can directly equivalent the power. So I can easily say the x equal to 1 is our answer, right? This is our first method. Now if you want to talk about second method, another method. So from here, from this part, you can directly say the base is same, right? So I can directly add the power. So I can write 2 raised to x plus 1, which is equal to 4 raised to x, right? Now 2 raised to x plus 1 as it is, and I can also write 4 raised 2 raised to 2 and x as it is, right? So again, base number is same, so I can directly add the equivalent the power. So 2x equal to x plus 1, x equal to 1 is our final answer, right? Again, if you want to look another method which is very easy, which method? What is the question? 2 raised to x plus 2 raised to x equal to 4 raised to x. So if I take common 2 raised to x, it will become 1 plus 1, 4 raised to x. So again it will become 2 raised to x into 2 equal 4 raised to x, which is again same this thing, so x equal to 1, right? So as I said, you can apply different method for whenever you find real solution, right? So x equal to 1 is our only one and only real solution. But now let's talk about complex solution, right? This is going to be a very interesting part, so pay attention throughout the video, right? How do we find complex solution? So see, first of all, if I rewrite the question, 2 raised to x plus 2 raised to x equal to 4 raised to x. Now I can write this as 2 into 2 raised to x equal to 4 raised to x, right? So I can write 2 raised to x equal to 2, right? This much is clear. I hope this much is clear for everyone. Now here I have 2, so I can also write 2 as 2 into 1, agree, right? And whenever we talk about 1, if I want to write 1 in complex form, then I can write 2 raised to x equal to 2 into e raised to 2 pi n iota, right? This is the complex form of 1. If you want to find out how I got this, then I'm sure all of you know about this formula. If I have e raised to iota theta, then I can write cos theta plus iota sin theta, right? So this is same, iota and theta equal to, here I have 2 pi n. Why 2 pi n? For example, this is my complex graph, this is real axis, this is imaginary axis, right? I have written 1 as e raised to 2 pi n iota, right? So if I want to represent 1 in this graph, then this will be on real axis, right? Because here imaginary axis, imaginary part is 0, so I have only real part, so this is 1, right? And I can represent this already as r into e raised to iota theta. This is complex form, right? So what is r? Radius, which is equal to 1, right, into e raised to iota. Now what is theta? Theta is here 0, right? 0. If I complete one another circle, it will become 2 pi, another circle 4 pi, another circle 6 pi. So you can say it is a multiple of 2 pi, right? So I can, if I want to write in generalized form, then I can write angle as 2 pi n, where n belongs to z, right? It is an integer value, right? 2 pi is right. If I want reverse circle, then it will become minus 2 pi minus 4 pi, right? If I put n equal to 0, then angle will be 0, right? So I hope you got it why I have written 1 equal to e raised to 2 pi n iota. So now if I bring this 2 into denominator of this part, it will become 2 raised to x minus 1 e raised to 2 pi n iota, right? I hope you got this why I have written 1 equal to 2 pi n iota, right? So now again both the side, here I have 2 raised to x minus 1 and here I have e raised to 2 pi n iota. Now from this step I can solve this question by two methods, right? First of all, if I take logarithm both the side, right, then I can easily find out the value of x. But there is another way in which we don't have to take logarithm. Which way? Here I have 2, so I can write 2 as e raised to ln 2. Agree? So now if I put e raised to ln 2 instead of 2, then it will become e raised to ln 2 and x minus 1 as it is, which will be equal to e raised to 2 pi n iota. Agree? So both the side I have exponents base, right? So I can directly equivalent the power both the sides. So x minus 1 into ln 2, which is equal to 2 pi n iota, right? So now x minus 1 equal to 2 pi n iota divided by ln 2. So what will the value of x? 1 plus 2 pi n divided by ln 2 into iota, right? So this is our complex answer, right? 1 plus 2 pi n divided by ln 2 into iota. This is real part and this is imaginary part. Now pay attention. If I want to find out the real value, right, which I got 1. If I want to find out real value from this equation, then what will I do? I will keep the imaginary part 0. And how will I do that? By putting n equal to 0, right? So if I put n equal to 0, I will get only x equal to 1, which we got earlier, which is our real value, right? Real value meaning imaginary part is 0. If I want to find out only imaginary part, then real value is 0, right? And if I have both the part, means real and imaginary, that will be our complex solution, right? So this is a very little difference between all of these three things. I hope you got it. This is our complex solution and this is our real solution. So if you have any query, doubt, then you can directly comment me in the comment box. And thank you so much for watching this video.